Let's take a look at another example. A batch of 75 washers contains 8 in which the variability in the thickness around the circumference of the washer is unacceptable. A sample of 10 washers is selected at random. If none of the washers in that 10 are unacceptable, then the batch is deemed okay and it's sent off to purchasers. This is a form of acceptance sampling in quality control. A sample of output is tested, and if the sample is deemed acceptable, then it's sold. What's the probability that none of the unacceptable washers is in the sample? Okay, so we have a population of 75 washers. Okay, we know exactly what the population looks like, and it has 75 washers in it. And we know that there are R equals 8 unacceptable washers in there. And we know exactly how many unacceptable washers are in that 75. We know exactly what that population looks like. Okay? And we are going to pick out a sample of size 10 from that 75. And we want to know what's the probability that we get no defects in that sample of size 10. Okay? No unacceptable washers. So let's name random variable y. That's the number of unacceptable washers in our sample of 10. Okay? And we want to know what's the probability that we see no unacceptable washers. What's the probability that x equals 0? Okay? That is, so this is a hypergeometric problem. Okay? From those 8 unacceptable washers, we want none. Okay? That must mean that we're going to choose our sample of 10 from the washers that are okay. And there are 66 of those. Okay? Pardon me, 67. 67 acceptable washers. Okay? So that's the number of ways that we can pick a sample of size 10 that has 0 unacceptable washers and 10 acceptable washers. How many ways are there for us to pick a sample of size 10 from the 75? That's just 75 choose 10. Okay? And if we work that out, we get 0.2992. Okay? So what's the probability that we see no unacceptable washers in our sample of size 10? 0.2992. Okay? That is roughly 30% of the time, if we choose a batch of size 75, we pull 10 from that, we're going to see no unacceptable washers about 30% of the time. So let's move on to another example. What's the probability that at least one unacceptable washer is in the sample? Okay, at least one. What's the probability that x is at least one or more. Okay? Well, this is the complement of what we already calculated. Remember, we have what are our different options for the number of defective washers, the unacceptable washers that we see in 10? Well, we could see none of them, 1, 2, all the way up to 10. Okay? If we want one or more, that would be all of these. We'd have to enumerate all these probabilities individually. Probability x equals 1, probability x equals 2, all the way up to 10. Okay? Or we could just take the complement of the probability that x equals 0. So we have that here. What's the complement of the probability that x equals 0? That is 1 minus 0.2992. And that is, as it turns out, 0.7008. Okay? So if we pull a sample of size 10 washers from the 75, a batch of 75, roughly 70% of the time, we're going to see one or more defective washers, unacceptable washers, in that sample of 10.